NASA's Spaceward Bound project was established in 2006. It's an outreach initiative aimed at educating people around the world. A team of NASA scientists travels to different countries, involving educators in real planetary exploration fieldwork on Earth. Now, for the first time, the team has come to New Zealand, and Aziz Al-Safin went to meet them.
And that's going flat out. That's incredible.
He's known as Junior, but he's a big part of the mission to discover life on other planets. A prototype rover similar to the ones on Mars is here with NASA as a part of Spaceward Bound.
And liftoff.
Aimed at educating and training the next generation of space explorers around the world. It's the first time the project has come to New Zealand.
So this is a huge feather in our cap, and it really is going to help put New Zealand on the map in terms of astrobiology and also space research in general.
This is very exciting. I heard about Spaceward Bound in 2011, and I dreamt to having it in New Zealand, and been thinking ever since. And really, it's a historical day for me.
Touchdown confirmed. We're safe on Mars.
The goal is to pass on the knowledge from professional NASA scientists to tertiary students and eventually school children.
Science is one of those subjects that we're really trying to encourage children to take part in more. And astrobiology is a great platform for that, because what it does is it brings together different scientific disciplines, everything from physics to chemistry to biology and even robotics and engineering.
While Junior's here, he'll be used for tests on Rotorua's hot springs, similar to the testing rovers Curiosity and Opportunity are doing on Mars as they search for signs of life.
I'm really excited to be in New Zealand because of all the geological and microbiology features in New Zealand, and New Zealand's a great setting for a lot of planetary analog environments, and we can find them in a essentially close geographical area. So that's exciting.
NASA mechanical engineer David Wilson is the brains behind Junior.
On Mars, you could be up to 50 million miles away from your robot. Commands take at least 20 minutes or more sometimes to get from here to there and back again. And in that 20 minutes, if your rover's driving too fast, it could hit a rock, turn over, fall into a crater, fall off a cliff.
Today, though, there were no cliffs, just a GoPro that was in the way. And although he won't ever make it there, Junior still has a role to play in the search for life on the Red Planet. Aziz Al-Safin, 3 News.
And joining us now to discuss the Spaceward Bound project and more is NASA senior scientist Chris Mackay. Good morning, Chris.
Morning, good to be with you.
Now, the aims of NASA with the Spaceward Bound project, what are the essentials there?
Well, there's educational aims, of course, as you just heard, but the scientific aims are to explore the ability of hot spring deposits to preserve evidence of life. Suppose we go to Mars, we find ancient hot springs. They're long since dried out, gone, dead. But could the minerals that form in these hot springs hold biomarkers that could tell us the kind of life that was in it? That's the main science question we'll be addressing in the hot springs in New Zealand.
And, of course, the big question for many people, is there life on Mars? What's the evidence like at the moment?
Well, right now the evidence is pretty thin, and that's what we're trying to go search for. And we think the sort of mineralization that occurs in hot springs is a good way that evidence could be preserved. On Mars, the evidence we're looking for is probably very old, millions or even billions of years old. We don't think we're going to find anything that's alive and squirming around right now. We're going to be looking for biomarkers preserved in sediments. Sounds kind of dull compared to something alive and growing, but it is definitely evidence of life.
Chris, how far off do you think it will be before human beings will be sent to Mars?
I think it could be quite some time. I would guess it's 30 or 40 years at least, and that's part of the reason why we want to get the next generation involved. They may be the generation that actually goes to Mars.
And the discovery of the Beagle rover, how significant was that?
Well, I think that's very exciting because it shows that Beagle 2, at least it died trying. It landed on Mars. It put out its solar panels. It had some measure of success, we now realize. We weren't able to communicate with it. ESA didn't ever receive a signal. But we now see that it did do something on Mars. So that's kind of satisfying.
But it is a dead beagle now, is it? The data that it may have got, is it unobtainable?
Yeah, directly we will get no data from it, but indirectly its success on landing and its deployment, even partially of its solar panels, provides engineering input that will help design and confirm the design of future such landers.
Now, what about the Curiosity probe? How are we going with that?
Well, Curiosity is working on Mars. It's in Gale Crater near the equator. It's heading up the mountain in the middle of the crater called Mount Sharp, looking for evidence of sediments that were deposited in water and searching for organic material. Our biggest recent discovery is that indeed we did find organic material in some of the sediments in the crater. This is the first clear evidence of organics on Mars. So that's an important step forward.
I guess you'll probably have the skeptics out there saying, why are we, or why is NASA spending all this money trying to find out the answers to these questions? Do you think it is worthwhile, this sort of expense?
Well, certainly I do, since I'm involved in it, but I think it's a fair question, and I would give two answers to it. And in some sense, both answers are part of the Spaceward Bound activity. One is space exploration and searching for life is incredibly motivating to students and to the public and to scientists in general. That's sort of a soft answer. The hard answer is that if we find life on Mars, if we find biomarkers, then that may tell us something about life, something about biology. And that's something that we learn may be new and important and help us understand biology and biochemistry here on Earth, where biology and biochemistry are very important technologies, very important to medicine, agriculture, pest control. Anything you think of, biology is often playing a role. So there's a motivational answer and I think a hard science answer as well.
Okay, well, thank you very much for your time there. That's Chris Mackay, NASA senior scientist, speaking to us from California.